Let's take a look of how this hybrid hierarchical k-means clustering working in a one-dimensional example. As we mentioned in our earlier class, the idea of this new clustering algorithm is that we want to combine the benefits or the advantages for both hierarchical clustering and k-means clustering. Since both of them have some problem. For example, k-means clustering requires the number of clusters in advance and choose initial centroids randomly, which means it is hard to start k-means clustering because you need to provide those informations. On the other side, hierarchical clustering has no problem to start because it's just build up a distance matrix starting with the smallest number. So there's no problem of hierarchical clustering. The only problem of hierarchical clustering is that once you merge everything into one gigantic cluster, you need to have a cut to separate the clusters. In other words, it's hard to find the place to the end of it. Therefore, the idea is that we want to combine the two. We start with the hierarchical clustering, and then at certain point, we switch to k-means clustering. At the time of the switch, the number of the clusters is generated as well as the initial centers are generated. And then k-means will be able to continue their work and then finding out all the clusters. So here is the pseudocode of how is it going to work. And let's take a look of the example to really visualize the work of this clustering. So we're going to use a one-dimensional data example. This is the one-dimensional data. There are 15 points. And we will just use the centroid concept. So to represent the center of the cluster, we use the average of all the points in the cluster. So you can see that in the beginning, we have all the points stays over there. To initiate it, we build up a distance matrix to look all the 15 points, build a two-dimensional array to store the distance matrix. So we need to go through one by one, and therefore you can see that starting with a node of 2, you calculate all the distance with all other points, and then you continue doing so until you fill up all the data. So of course, because this is a distance matrix, the diagonal value will be all zeros, and we only need a triangle part of the distance. That's going to be sufficient enough. And once we have all the distance, you need to think as a computer. The computer will go through a nested for loop to scan all the values one by one and then find the minimum value. In the case of if we just simply use the minimum value, if the minimum value is greater than the current value, then we will replace the current value with the minimum value. In that case, you can see that the first value of 1, which is the smallest value we found it, we will stay over here. In the later part, even though I find another one, they are equal, which is not less than the current minimum, so they will not be selected. And therefore, once we scan through, or the computer scans through all the values, it will state this, the very first one that it sees, indicating it is the current minimum. So what's happening is that it will try to merge the node 2 and 3 into one cluster, and therefore we will form our very first cluster. Once the cluster is formed, the data need to be updated. Now we have one data less, and then so that the point of 2 for the row and the column will be deleted. Instead, the points 2 and 3 will be merged together. And like I mentioned, now the center of this cluster is going to be 2.5 because it's the average point of 2 and 3. And we, of course, need to update all the values that we have, and then we will be able to continue scan the minimum value. And as we mentioned earlier, now you can see that the points of 2 plus 3, which is this 2 point with the distance of 4, is becoming, with the point 4 has the distance of 1.5. It has been changed. And then we will scan through all the values every single one of that, it will find the next value of 1 as the closest point. So you will try to merge the two clusters together. So we will form 9 and 10 become another cluster. Now we have two clusters. And then we will need to do the same thing. Delete the row of 9 as well as column of 9 and then update the value of 9 and 10 now. So we will have all the values being updated. And by doing so, we will have the new values for us to see. And then we will need to scan through all of the data, finding the minimum value. So now we will see 11 and 12 are the 2 points that are closest to each other. So we will merge the 2 of them, delete the row of 11, column of 11, forming a new cluster, and then update the values. So now we are generating 3 clusters. So we will continue doing the same thing, scan through the whole thing, finding another value of 1, indicating 18 and 19 need to be merged together. So we will merge them together, update the data. Now we have 4 clusters. Once we are done with that, we will continue scanning the minimum value, find another value of 1, which is 23 and 24. We will repeat the same thing. So merge the two, 23 and 24, updated the data value, and now we have a new distance matrix. At this moment, we have 5 clusters. And while we try to scan through the whole data, you will notice the minimum value is no longer 1. So again, you need to search for the minimum value with all the existing values. We will find a 1.5 here and here. And of course, since we use the same code, the very first 1.5 will be used to merge point 23 with the point of 4, forming another bigger cluster, but still have 1 cluster here, 2, 3, 4, and 5. So we have 5 clusters over here, updating the data, getting a new distance matrix like that, and then scan for the next minimum value. So now we have 1.5 over here, indicating we need to merge 23, 24, and 25 together. So we are forming all them together, still with 5 clusters over here, with 2 clusters of member for 3 numbers. Another 3 cluster has 2 numbers are forming together. We look through the updated value, search for the minimum value. Now we are finding out 9 and 10 as 1 cluster need to merge with another cluster, which is 11 and 12. So basically, these 2 clusters are going to be merged together. So you can see this is an important step because this step will reduce our number of clusters to 4. So you can see now we have 1, 2, 3, 4 clusters over here. Updating the data, search for the minimum value. We found a minimum value of 2.5, indicating the node of 16 need to go into this cluster. So we will combine them together. Still 4 clusters now, updating the data. And then what we will need to look into here is find another minimum value of 3.5 over here. In this case, node 7 will be merged with this big cluster and then forming a 4 cluster information. In this case, we try to update the data, finding the minimum value of 6. So you can see that at this time, this value, minimum value is actually pretty big. This 6 indicating the node of 30 will need to join with the clusters over here, forming another still 4 clusters, but this cluster is actually a big distance over here. I want you guys to notice the node of 30 was intentionally to put pretty far away, kind of treated as an outlier, but I want you guys to see how does this being work together with the whole clustering process. Once that is done, we will need to update it, find a minimum value. Now it's time to merge the 2 clusters together, forming a big cluster. So at this moment, I have 1, 2, and 3 clusters. Once that is done, search for the minimum value. Right now, there's only 3 values to compare. Minimum value is 7.8, which indicating that I need to merge these 2 clusters together, forming a 2 cluster result. And of course, the last step would be merge everything all together to complete the hierarchical clustering. As I mentioned, this is the whole process of hierarchical clustering. Where do we cut the hierarchical clustering? Well, generate a different number of clusters. And that's why it's pretty difficult to find a good place to cut it. And therefore, the idea of hybrid hierarchical k-means clustering is that we try to keep track of how many number of clusters are generated throughout the process, which is this figure. And we want it to stop basically at the point that gives you the highest amount of the cluster at the latest stage. So you can see that although there are three steps are giving you 5 clusters, we want it to stop over here. And if we stop over here, basically we rerun the hierarchical clustering until this point, we will stop at this stage. So once this stage is found, basically at this time we have 5 clusters and we only have 3 points have not been decided yet. So you can see that we switch at this stage, we switch to k-means clustering with k equals to 5. And the center of the clusters are already decided, which are the center for each clusters. And we don't want to change those data away so that we will consider point, for example, 9 and 10 as 1 point, 11 and 12 as another point, 2, 3, and 4 is another point. So they always stick together because they are generated from hierarchical clustering. And then what we're going to do is for the points that are single, they are alone, they will going to find the closest cluster to join. And we will repeat the process just like k-means clustering until there is no change. And basically, we will be able to find there are 5 clusters in this example through the novel hybrid hierarchical k-means clustering, generating 5 clusters with each one of them has the following members. That is how we are going to do through this interesting algorithm.